All right, so we are doing classical mechanics, trying to use all those formulas of classical mechanics and use them to derive with our own kind of questions, to solve those questions, to understand it better. Last time we tried to understand the friction, how friction stop an object and a moving object. This time we're gonna do. Remember last time we covered that the friction of force. Now this time we're gonna do a more important formula, the force due to the gravity. The formula is z. This is a constant, m1 m2 over r square. Okay, so let's make a question using this formula. What formula tells us that? Formula tells us that the force due to gravity is equal to z. Z is a gravitational constant, which is 1.67 times 10 negative 11, I guess Newton, kg second square. Right, so okay, so let's try to come out with a question using this formula. Two object of 50 kg and 10 kg apart, by 1 meter. Find each object exert force on other. Okay, so what do you think? How are we gonna solve this question? Let's see. So force due to gravity is, we have our gravitational constant. This is 1.67 times 10 negative 11, and then we have 50 kg, and then we have 10 kg, and they are apart by 1 meter, so 1 square. So let's use a calculator and let's see. 1.67 times 10 raised to negative 11 times 50 times 10 gives us a very small number, 0.00001, 2, 3, 4, 5, 6, 7, 8 Newton. So the object A exerts this much force on object B due to the gravity. So we just solve the Newton gravitational formula, this one. So let's move to the next one, which is similar to the one we already did. So the gravity is, F g over what mass, right? So it says that the gravity, which is just acceleration, is equal to force due to the gravity divided by mass. So that's the formula. Let's come out with, let's make a question. Let's see, what can we write? Let's say the acceleration due to gravity on moon, the acceleration due to gravity on moon is what? I guess I'm not sure, 1.8 meter per second square, I guess. Little bit more or little bit less, but that's what I remember. Find okay, so find the force due to gravity of, find the force due to gravity of, find the force due to gravity of an object mass whose mass is 50 kg. Alright, so now you know that the acceleration is proportional to force due to gravity divided by mass. We are trying to find this one, so we do the cross multiplication. So force due to gravity is mg, which is m is 50 kg and z is, I guess, 1.8 meter per second square, right? So 50 times 1.8 is 90 Newton. So the force due to gravity on that object, which is only 50 kg, is 90 Newton. 90 Newton. What would be the force due to gravity on this object if that object is happen to be on Earth? Okay, let's see. Fz is mz. All right. So z of Earth. So m is same 50 kg, but the acceleration due to gravity on Earth is 9.8 meter per second square. So is 50 times 9.8, which is 490 Newton. So we see that the object on the moon and the same object on the moon and same object on the Earth is not the same thing. In fact, the force due to gravity on the same object, if the object is on the Earth, is much higher than if it is on the moon. Why? Because the Earth gravity is much higher. How much higher? Is a lot higher. The moon acceleration is 1.8, the Earth acceleration is close to 10. So that's why it makes a huge difference. What does it mean? It means an object that is on the Earth, maybe you and me, we don't have hard time working on the Earth. Why? because the force due to gravity is really high. We can walk without any problem. But if we if you read the biography of Neil Armstrong, you know that, or if you saw that moon landing, you will know that you might observe that he had a hard time walking on the moon. Why? Because the force due to gravity on the moon is not that high. So Neil Armstrong, when he was walking on the moon, I guess 1969, he really had a hard time walking on the moon because the gravity is not high over there. That's why it is important. This is important. We need that much of gravity, that much of the force that Earth pulling us. Otherwise, it would be very difficult for us to walk or to live over here.